Alright, in this video we're going to discuss derivatives of inverse trig functions. And the inverse trig functions, the derivatives of them are not that common, but they are used, and they will be on the AP test, but probably not very prominently. So an inverse trig function, one that we know is y equals inverse sine of x. And remember that they find angles, so y equals inverse sine of x, or another way to write it is y equals arc sine of x. And they still use both. They haven't decided on one. Some people prefer one over the other, but we want to take the derivative of this function. Well, if y is the inverse sine of x, that means that x equals the sine of y. Y is the angle and x is the sine of that angle. And that's how the inverse sine works. So if we want to differentiate that, we have to differentiate using implicit differentiation. So the derivative here of x is 1 equals, and the derivative of sine is cosine of y, tack on the y prime, and then solve by dividing both sides by cosine of y. Okay. Now the issue with that is that there's no x. We want to have x to plug in. We have cosine of y. This is not wrong, but it's not in the form we want it. Okay, so what we're going to do is take that, and something we know that sine squared of x plus cosine squared equals 1. That's one of our Pythagorean identities. And we're going to solve that for cosine. So I would have if I subtract sine squared from both sides, I would have this, and then square root, I'd have cosine of x equals the square root of 1 minus sine squared. So this, if I replace this, then 1 over square root of 1 minus sine of y squared. But you're saying, what, that doesn't help us any, but it really does, because back here we had that x equals sine of y. So that means that sine squared of y is going to equal x squared. So we can replace this 1, and then it's the square root of 1 minus x squared. We replace this, gets replaced, and goes to that. And so that is the derivative of the inverse sine, then, is 1 over the square root of 1 minus x squared. Okay. We're not going to go through every proof, but I wanted you to see where at least one of them comes from. And this is one of the two most common ones when we talk about the derivative is 1 over the square root of 1 minus x squared. The other most common one is the tangent, inverse tangent. Okay? And that equals 1 over 1 plus x squared. Okay? Now, of course, we do have ones for the inverse cosine, which is the same as actually the inverse sine, except it's negative. And the derivative of the inverse cotangent is the same as the one for tangent, except it's also negative. And let's finish the bunch by taking the derivative of the inverse secant. Again, we're not going to go through the proofs of all of these, but that is 1 over absolute value of x times the square root of x squared minus 1, and the derivative of the inverse cosecant is the same as that last one, except it's negative. Good. Now, let's look at an example, and I want to change this example. I want to make it y equals the square root of the inverse cosine of x. Okay? So first of all, this is a chain rule. This is a chain rule. We have a function inside a function. Our outside function is the square root of u, and u is the inverse cosine of x. So I have to use the chain rule in order to differentiate here. So the derivative of the outside would be 1 over 2 root inverse cosine of x times the derivative of the inside. The derivative of the inverse cosine, we just learned that, back up here, is negative 1 over the square root of 1 minus x squared. That is y prime here. Now there's not much simplifying that you could do other than just combining the two fractions into one, but multiply the denominators and the numerators, but you're not going to really simplify it all that much. That is our derivative. Okay. Let's get another one. I like, when they say arctan, I like to rewrite it with that, the tan inverse. I just like it better. Okay, it's just a personal preference. But we can see here that we have a product rule. We have a first and second function, so we've got to have a y prime is going to be the first times the derivative of the second plus the second times the derivative of the first, which we know is 1, derivative of x. And so this is x. The derivative of the inverse tangent we learned is 1 over 1 plus x squared. And this one just stays inverse tangent of x. And that is our derivative using the product rule. Okay, so all those things that could come up, they also come up here. Right. And as it said, the functions inverse sine and inverse tangent show up the most often, but we need to know them all.